Good. Hello, welcome. Week 11. We're finally in November, so that's good. 7 weeks of class, including this one, and for you guys, two more projects. So this is a project-based class. We have a project in the works right now, and I'm bringing that up because like I did last week, at the end of the regular content this week, I'll put a break in the video so this can be more easily found, and I will continue working on um, a what's the word I would use for it? Well, a demonstration of some of the techniques that you might employ to do the third project. It's the first project where you've been allowed to been given a great deal of freedom to be creative if you choose to be. So that's something to look forward to, and hopefully you will take my advice and start thinking about that project, if not planning for and building it sooner than later. Of course, I can't come to your house and make you do anything, but that would be my recommendation, so that you don't get to November 20th, the Sunday before Thanksgiving, and find yourself having to figure out how to do a more complicated project than the first two. So the time to start was last week when I started Project 3, but if you haven't started, then start today if you can, or at least this week. Okay, so we're in November. It is week 11. That's all good news in terms of progressing through to the end of the semester. Let's go poke around, see what's going on in the class. So we are on week 11, which is slices. You're going to find almost well, no, that's not entirely true, but you're going to find a very similar lab this week. Because slices are very similar to arrays, but they have some slightly different features to them, even though much of the same code applies to arrays and slices. So some new stuff, some repeat of the same stuff that you do with arrays, you do on slices. The main difference between an array and a slice is that an array has a predetermined and fixed size to it. So if you create an array for 10 elements, it can only ever hold 10 elements. Whereas a slice can start at 0 elements and grow over time. So a slice is a dynamic collection that can grow, and also we'll see be shrunk over time as we choose. Some people will think that slices seem easier and more convenient in some ways than arrays, but you need to know how to use arrays in computer science at the very least, because many languages lean pretty heavily on the concept of an array. So you need the array, if nothing else, as a building block to understanding the concepts that are then used and adapted to other kinds of collections. For us in this language, it will be the slice as a comparison to the array. And slices build upon many of the same concepts as arrays. Okay, that's week 11. And then individual project 3, which I will pop up. And then after the break, at the end of the regular content, I will go read through it again. This is something that I don't technically need to do. It's something that you need to do, but I'm doing it as an assist, because I would like those of you who have put all the work in up to this stage of the semester to get the best result around what you imagine for your project 3. So hopefully I can help with that. All right, let's look at week 11. And then I'll do demos. Well, what do I have? How do I have it listed? Lab 10. Yeah, I'll do the lab. I've only got one demo from lab 10, so I'll just hold off on that until I have my REPL set up for working with slices. Okay, so we will see that slices and arrays have a lot of similarities and kind of two primary differences in my opinion. We'll talk about those. We will create empty slices, which are slices that start with 0 elements inside of them. We will add elements to slices. We will access individual elements of slices, which is the same as accessing elements of arrays. So when you hear the word slice and you hear the word array, it's, in my opinion, easiest to just think to yourself that a slice is just a more flexible array, but it shares much of the same syntax. So we use the length function on slices to see how many elements are in it. We use zero-based indexing on slices, just like we do with arrays. We use counting loops with slices and range loops with slices, just like we do with arrays. So you're going to see a lot of familiar code. So readings, of course, on a variety of those things. We're also going to do an actual algorithm this week. I'm going to help walk you through it because some of you might find it a little bit overwhelming at first, but it's one of our first actual sort of algorithms that does something slightly more complicated with more steps involved than we've done before. Manipulating strings that we have stored in slices. So I'll walk through that one as part of my lab tips for the week. But we are going to use the strings package, and then we'll get to explore some of the things you can do with the strings package, and maybe run several experiments with them. Homework, as always, based on the readings. Lab, let me pop that open, and then I can come back to it. So there is no unit test. Like last week, it's the result of the lab program this week is going to look very similar to the result of the lab program from last week. So there's no unit test, but there will be a running program that you can use to test whether or not your code did correctly. Yeah, come back to that stuff in a moment, but no unit test this week. Discussion. So we're dealing with strings in our algorithm this week. So this would be a good time to go do a little bit of research on the concept of a string in computer science. Strings are actually very complicated things to deal with on computers, and programming languages have a lot of different techniques for doing strings. Now, you know what a string is in the Go language. It's the things with double quotes around it. You can declare string variables. You can take one string and use the plus sign to add more string to the end of it, which is called concatenation. We have a strings package that allows us to do a variety of operations on strings in the Go language. So the goal this week is to go kind of like we did with if statements and loops, see kind of what strings look like in the rest of the computer science and programming language world. I think Go strings are actually pretty well done, and they're among the easier types of strings for a programmer to deal with through the Go language. And then the reminders, as always, so homework lab discussion, and then individual project 3 is due November 20th. You may have other classes and you have other teachers who are trying to do you a favor by letting you finish something big before the week of Thanksgiving when you may have lots of distractions. But I also know that means that the week before Thanksgiving could be very busy with exams and papers and other things. So that's just something to be aware of and plan for accordingly. Well, it doesn't matter. It's due on November 20th, so no matter what your week of Thanksgiving looks like, you will have the big project knocked out for this class in advance. We will have a normal content week the week of Thanksgiving. If it were me, I would do what I'm going to do. Well, as an employee of Butte College, we get basically Thanksgiving Day off. But for me, what I've always done for the students' benefit is try to just get all the work knocked out in the first couple of days of the week. So hopefully you will follow me on that. You will have a project done, and then Tuesday, if it were me anyway, I'd just try to knock the week's work out, like on Tuesday or early Wednesday, if I had Thanksgiving plans. Traditionally, we just didn't do it because it was just too inconvenient to only have the one day off to do anything. Okay, so that's all of that stuff. Let me switch to REPL it. Create one for this week. All right, first thing I'm going to do, though, is do a demo. Let me make sure you can see what I see. You can. So let me have one person's code that just stood out a lot for the lab last week. So I thought I'd show you this one person's code, which you might even be able to tell already that something interesting is going on here. But this is what one person did with the lab last week. So you might ask yourself, how did they get so good that they can do this on their lab? Because this person has been doing this on every lab all semester. Many of you have actually done that, so you know what this feels like. You put the extra work in every week on the lab to do a little bit extra, to press yourself to learn a little bit more. And it grows. You find yourself not just that little step ahead of where the course content is, but like increasingly large amounts of space between you and where the basic course content is. So I just thought this one looked really awesome. This wasn't hard to pull off, but the person spent the time to do it, which was really, really cool. Have the little sections like this. It looks really, really pretty. This person did the extra work to show 1, 2, 3 and not 0, 1, 2. Also capitalized them, which was pretty cool. Many of you did the 1, 2, 3, so that was cool that you did that. And then also a fair amount of you actually tried the little tip that I gave you to align the text and managed to pull this off where your shopping list looks really pretty like this. So of course that was all in the video, but some people did and some people didn't try it. Anyway, very cool lab that person did. So I wanted to show that off because I respect the extra effort that took to do that, which is simply a matter of, am I going to put extra effort in or am I not? And it pays dividends to do so. Okay. So we're doing slices this week, and I will just do a small comparison. So we will say, I don't know. Our numbers, 5 integers. This is an array. Nothing new here. Numbers. I don't know, counters, let's say. So what can we immediately tell about the slice is that there is no number in the square brackets, and that's important because slices can start with 0 length. So let's just do, for comparison's sake, we will say length of numbers and then length of counters and let's also print them out in their default format so we can see what they look like. So notice that everything is the same between them except for when I initially declared them. So I declared numbers to be a size 5 integer array, which means that it has indexes 0, 1, 2, 3, and 4. And then I declared counters to be an empty slice. So how do I know that counters is a slice and not an array? Because of the way I created it. It's entirely in the way you create it that makes it a slice. If you put a number in the square brackets, you have an array. If you don't put a number in the brackets, you have an empty slice. And we can see that when we run it. So the length of the numbers is 5. It is 5 integers in their 0 state. The length of counters is 0, which is a slice. The contents of counters is nothing. There's nothing there. So there's a slice. And there's an integer, and I'm going to comment out the integer one for now because we are interested in slices this week. So there's an empty slice. What is the value of an empty slice? Well, you can do things like this. Let me get myself an input integer, and then I'll use a counting loop. And let's just put, well, we'll just put 5 counters in there. So notice I hard-coded the 5 because I'm working with the slice. So this, if I put the length of the slice here, well, that's 0, which means the loop will never execute. So I need to be careful when I'm using the length of a slice that I mean to use the length of the slice and not something else. If I want to put 5 integers in my empty slice, then I need to make sure that I code in the fact that I want to do this 5 times. So I'm like literally hard coding it because I can't lean on the length of counters, that's 0. So I will just code the fact that I want to do 5 inputs. I plus equals 1. So we will prompt counter number D I. We will scan the integer. And then we'll do the new thing. So how do you put a new element on a slice? You append the element to the slice. So what we do is we update counters by appending to what it currently is something new. Do I need to put the counters equals part? Oh, we'll find out. Yeah. Clear that. Okay, so what am I doing here? This is new. New item to a slice. You cannot do this with arrays. So this whole operation, so I'm going to prompt for an input. I'm going to scan the input into an integer variable, and then I'm going to append that input onto counters, and then I'll take the newly appended, the counters with the newly appended data, and I will more or less replace counters with the now new one larger version of itself. At least that's how I explain it to people at first. So I will get on all new counters, which is the result of appending whatever counters used to be with this new input. So let's run that. Oh wait, I forgot to do, I did it again. What we want to do at the end is we want to see what the length of counters is after the fact. So what it should be is the length should be 5 because I will have repeated the process of prompting for scanning in and appending inputs 5 times. And I should see the contents based on my inputs. Now I'm going to input 10, 20, 30, 40, 50 when I run it. And what should happen is 10 is appended first, and then 20 is appended behind that, 30 appended behind that, and so on. Hopefully. 10, 20, 30, 40, 50. So there, now I have a slice that is of length 5, and it has 10, 20, 30, 40, 50 because each one is being appended to the back of the slice. This is kind of the big magic of the slice, is that you can append things to it. Next week, we will look at ways to cut things off of it, but for now, we're just going to be able to add new things. You can also append things non-interactively, so you can take whatever it is and append a, let's just say a -1 to the end of it. If I do that, I should have a length 6. I'm gonna, you know what I'm gonna do? I'm gonna say 1. So that we just use counters. I'll use numbers here just to remind myself which stage I was at. So there's after that append. So I should get a length 6 with -1 at the end after I manually append this. So there's step 3 has now 6 because I appended yet another one, and that -1 is at the back because that's what appending does. You can also append a whole bunch of stuff at once if you want to. So let's append, oh, I don't know, 10, -20, -30. You can also append multiple items at once if you want to. And then we'll see what the length at step 4 is. Oh, I'm getting tired of this. So there's the -10, 20, and 30. It is now a length 9 after all of that sequence of events. So that append, that's the big thing with the slice, is that you can append to it. You can also loop it with counting loops and range loops. So I have not looped the slice. I just did a 5 times counting loop. But now let's loop the slice itself. So counters. Here, that's really the best option by far. And I said it last week, and I'll remind you this week. Whenever you are referring to the length of a slice or an array, do it computationally. Don't hard code this number. If you find yourself hard coding the length of something in Go, you're doing it wrong. You're absolutely doing it wrong. Because you have embedded a piece of hard code in a place that can eventually lead to a bug. So never hard code the length of a slice or array in the Go language. Always do it computationally. And for those of you who got around computing the average by hard coding the number of elements, I sent you a note with your lab feedback about how we all solved that problem, which was in both Piazza discussions for both sections. So like I say every week, I encourage you to use Piazza to help yourselves, help each other, let me help you. So anyway, both sections had the discussion about how do you get that length of the array to be a float, and both sections had people figure that out and share the answer. I didn't, because someone had already answered it. Okay, so now I am using a counting loop over the slice. I have to use the length computationally when I'm looping a slice, because the slice can change over time. So technically with an array, I might be able to get away, even though it's a bad habit to be in, with hard coding the length where I need it. But with the slice, that's always a terrible idea, because slices can grow. And they can also, by the way, shrink, even though we're only going to grow them this week. What am I doing with it? Let's do this. So what I'm doing here is I am multiplying. So I'm using the I as an index, starting at 0, counting up 1 at a time, stopping 1 short of the length. So remember, if we have a length 9 slice, the indexes are going to be 0 to 8. So this will go from 0 to 8, multiplying each element by 2 and storing the new multiplied by 2 value back over the top of the original location. So there's a counting loop over the slice. Here we'll get a range loop to print the slice. I'll do the same kind of square. Oh, you know what? I'll put parentheses just for fun this time. So a range loop. So after I double it, I'm going to use a range loop to print it and see if my values look like they are doubled. I'll leave that for a sec and sip this tea. And because I'm using both the I and the N, except for I'm not, now I am. Because I'm using both the I and the N as part of my loop, in the range loop, I'm not ignoring either of them. I'm keeping both. I'm not using the underscore to ignore either part. So let me run that. Still got to do the dumb inputs, fine. Now there's me appending. Now invisibly, they were all doubled. But I can look at the number 4 contents and then see if the doubling did in fact work, which it did. So 10 became 20, 20 became 40, negative 30 became 60 from the other direction. So there is my integer slice. Notice that the counting loop on a slice and the range loop on a slice are the same. They're exactly the same as an array. The only difference is the way you create one. This is one of the 2 ways you can create them. So the way you create them and the way that you append things to them. And you can append one thing at a time, or you can append many things at a time. So they're not that bad if you are fresh, if you are fresh on arrays, which we all are because we did them last week. So range loop's the same, counting loop's the same. It's how you create them and how you add things to them. That's the different part. So let's try the other technique. I'm going to comment this one out and make a new one. Let's do the other technique for creating slices. Okay, so there's another technique for creating slices. Sometimes when you create a slice, you have a starting amount of data, but you also want the ability to add more later should you choose. So you can actually make a slice that starts with a particular number of elements in it that then can have more added on later, and that looks like this. Let's do, we'll do fruits. So we'll use the make function. What we're going to make is a slice of string. And initially, let's say that it will be a size 3. So let's look at that and see what it looks like. So how do I know it's a slice? Because there's the square brackets and there's no digit in there. If you see the square brackets and no digit, a slice is being created or passed around. Anyway, so this is a built-in function in Go. It allows me to make slices of certain sizes. So fruits will be a string slice that starts with the size 3, and let's look at it. Why I should just start right now, right? Just number it. Phase 1. And remember, this %v is super handy for testing purposes and learning purposes. It's often not the best thing for real software. So don't try to avoid using %v unless I've instructed you to do it. In your projects, don't use %v unless you can make a good justification for it. But generally, try to come up with some better way of printing the contents of slices and arrays than %v. Okay, so let's run this, and what we expect to see is a length 3 and what for contents. Well, you can't see it here, but you notice that the square brackets are apart from each other, and what that tells us is that there are 3 empty strings in there. So let's change one of them just for fun. I don't know if I have any chat folks around or not, but I'll ask and see if there are any of the people who are courageous enough to do chat. This is a position, a size 3 slice. So where will cherries be? Hi, Kevin K. Nice to see you. So where is cherries going in this fruit slice in terms of positions? First, second, or third? Second. Good one. So Kevin K is absolutely correct in chat. Cherries goes in second. I did not do any appending. All I did was overwrite one of the empty ones, the second position, with the word cherries. The length is going to stay the same. The contents is going to be different because it's going to be empty, cherries, empty, even though the empties are hard to see. So there's cherries, and what we can't really see, but what is true is that on either side of that is nothing. So notice, by the way, that accessing things in a slice is the same as accessing them in an array. Same thing. Let's go ahead and put some more fruits in there. I'm going to do something fancy. Not changing the length. So Kevin K, you might be on your own. So you don't let me wear you out if you just don't feel like answering. No need to answer, but so the question here is, what is this? Like, which element am I computing? Not quite. That's a good guess. So it won't overwrite cherries. So it might help to do the math in your head here and then sort of ask you what index something. So it won't overwrite cherries, but it gives us what index value. Two. That's right. Oh, so juice. It's 2. So the length of fruits is 3. Less 1 is 2. So it gives us fruits at 2. So the index we get from that little calculation is 2. But it turns out that this is, in plain language, the last item in the slice. So the length of a slice or array minus 1 always gives you the index of the last item in it. This can be very useful for things like slices when you don't know always how big they are. So you don't know how to hard code the last index, but you can compute the last index always by computing the length of the slice or array itself minus 1 and using that as an index. So that is a very handy little algorithm or hack, if you want to think about it that way. That is a good hack for getting the last element of any slice or array without having to hard code it, because the last element of any slice or array ever in Go is the length of that slice or array less 1. All right, so apples is in 0, bananas in 2. Oh, did I and cherries in 1. Okay, so they're all there. I did not change the length. It's still 3. So I should have apples 0, cherries 1, bananas 2. All right, as expected. So that is a slice that starts with a size, but because it's a slice, and we know that because it was empty brackets string, slice of strings, we can still append to it. And I'm going to go ahead and put a few. I'm running out of IO. Kiwis is one. Grapes is easy to type. Oranges is not in there. So I'm going to append a bunch. Yep, that's everything except for step 3. And then while I'm at it, I will say a string, and I will go to fruits, and then I will use the hack. So the last element, well, that's going to be the length of the same guy, less 1. It looks terrible in code. It looks messy and confusing. But if you learn to recognize it, it's inside of those square brackets and you can make sense of it. It's helpful. It's a helpful little hack. All right, the last element is in fact oranges, which I got at by computing the last index and not hard coding it. All right, so I added 3 more to the slice and it became a size 6, and then there's all the stuff in it. There we go. All right. So that's like all the stuff. 4 slices, all the basic stuff. I'm going to have us switch gears here a little bit and do an algorithm that's similar to the lab, and then I'll also help you with the lab hard algorithm. So you'll see it twice tonight. So here's a slightly fancier setup. Let's see, I will make a, I'll call it original colors, and I will make it, in fact, let's just do this. How do I want to do it? Yeah, let's do it this way. We will say 5 strings, and then red, green, blue, yellow, purple. So this is an array. How do I know that? That digit in the square brackets tells me this is not a slice, this is an array. What does that mean? Counting loops work, range loops work, the length works, printing with %v works. What doesn't work is append. You cannot append to an array. Let's go ahead and try it though, just to see what Go says. Should we try to append to an array? I don't actually know what the color chartreuse is. Is it a gold color? I don't know. I'm going to get an error here, but I'm doing this to remind you that you can't append to arrays. How do I know that it's an array? There's a digit in the square brackets. All right, so first argument to append must be a slice, and what we have is a size 5 array of string. So I just wanted to show you that. Okay, so here's what the lab problem is that you're going to see it twice. So what the lab problem imagines is I have a situation where I would like to have a version of all these colors that are capitalized, let's say. So the original data I'm given is capitalized. A green color. Thank you, Kevin K. Chartreuse is a green. I'll forget that probably, but thank you. At least for now, I know what chartreuse is. Okay, so here's the scenario that you're going to see repeated in the lab. Sometimes in programming, we have a set of data like these original colors, and we would like to have a variation on that original data without destroying the original data. So for our argument, let's just say that we would like to have a variation on these original colors. We want to preserve the original data, the original colors, but we'd like to have a variation of them where they're in all capital letters, let's say. So how do we do that? Well, one thing that we can do is we can create a slice that has the same number of spaces inside of it. At least this is how we're going to do it. We're going to create a slice. So a slice of string that is going to start with the same, with room for the same amount of original colors, which can be computed as the length of original colors. So we're going to end up, colon equals, we're going to end up with a slice here. So it means we could add more stuff to it if we want to. We're going to end up with a string slice that is the same number of starting elements as the original colors. So if the length of original colors is 5, then new colors will be length 5. For testing purposes, let's print that out. But that's what we want. We want sort of some kind of a scratch pad, if you will, or a place to do work with the original data without destroying the original data. So we'll make a slice. We'll make it have the same number of elements as the original does, which would be 5. And then we can do an algorithm to make the changes that we want. So let's say that we would like the new colors to be these same colors, but in all capital letters. Oh, Kevin K. Googled it. Well, that's what I would do. I mean, if I weren't in the middle of live streaming, I definitely would have Googled it. So thank you for Googling it. Now we both know, and then it'll be a matter of who forgets what chartreuse is first. Although I want to know, my guess is it's not a bright, pretty color. It's more like, I don't know, something biological. Anyway, so hopefully everyone's kind of following the scenario. We got the original colors. We don't want to mess with those, but we would like to kind of start a new set of colors as sort of variations on the original colors. So the first thing I do is I make a slice that's the same size as the original colors, and then I can populate it with the altered information from the original colors, and then if I want to, add more later as well. So now we are into a new thing, which is strings. So let me go, let me go back here. We have a slice of strings. We want to capitalize them. How do we do that? In Go, it's part of your readings this week, somewheres, there is a strings package. I'm going to go look at it. So you might remember we did one of these when we looked at FUMPT and when we looked at math. So now we are looking at strings. Strings package. So we are going to add an import for strings into our code because we're going to do some string stuff. Let's find something. Well, let's just see if there's something that looks like it would convert strings to uppercase. I already know that there is. There's a lot though. Clone, compare, contains. That is kind of, is this piece of a string, can it be found in a larger string? Bunch of goodies in here. The one we want, we might try to title as well. To upper. So I'm going to click on this. Returns S mapped to uppercase, and then the example says if I strings to upper gopher, then it comes out all caps. That's what I want, strings to upper something. Okay, so I want to cycle through the original colors without altering them and put them in my new colors as all uppercase. So how do we do that? We can use a counting loop or a range loop. I'm going to use a range loop. I in equals range over the original colors. So I need to loop through the original colors to get what I want. Hopefully you remember what this I and N pairing means. This I and N will be a pair of data for each one of these elements in original colors. Red will be I is 0, N is red. Green will be I is 1, N is green. Blue will be I is 2, N is blue. So the I is the index as we range over it, and the N is the data itself. The last one would be the I or index is 4, and the N or the value there is purple. Okay, so index will go 0, 1, 2, 3, 4, and the ends will go red, green, blue, yellow, purple. So fundamentally what I'm going to do though is I'm going to use the strings package and the toUpper function to take each one of those ends, red, green, blue, yellow, purple, and convert them to uppercase. But I want to store them somewhere. And where I want to store them is in my new colors slice. So the trick is, how do I get them in the right spot in new colors slice? Well, if new colors is size 5, then why don't I, which means that new colors has indexes 0, 1, 2, 3, 4. Why don't I just take position 0 in original colors and make that position 0 in the new colors? In other words, when I is 0, in original colors, I is 0 in new colors, and then 1, 2, 3, and 4. And then we'll do the quick print. So we just did an algorithm. We did not alter the original colors at all. We used them as our starting place. We created a slice of that same length, and then we loop through the originals, taking each one and converting it to all uppercase, and then writing that new variation on the original color into our new color slice. So at the end, what we should see is the original colors, but all uppercase. And if we want to, we can prove that we didn't actually alter the original, which is our intention, is line those up so it looks nice. So we didn't want to alter the originals, so our algorithm made a slice and then sort of copied the data over, making the alterations onto the copy and not to the original. That's the scenario that you're going to see in lab. And of course, at this point now, we can add more things to new colors by appending things. I don't know what mauve is. That's a color as well. So now we have new colors that starts with the original set of colors, but we're storing them in all capital letters, and now we can append more colors onto it. I'm out of color ideas. Why don't we go with some metallic ones? Just to show you that you can uppercase things in place. So that will be uppercased and then appended as the second step. And now we can look at that after we've appended a couple of more colors onto it. So that's kind of the scenario. I like the original colors, but I'd rather store them in all caps. And then I also want the ability to add new colors to the set, which I've now done. Okay, so you're going to see this similar scenario. There are other strings operations we could do. So let's see what else we have for Tues. ToTitle returns a copy of the string. What does title look like? That looks like all caps, basically. So that doesn't seem that different from ToUpper. What else is there? Is there like a capitalize or something? Clone, count, cut. I don't see a capitalize yet. Split. There's a ToLower. ToTitle special. Don't need that. Trim. Am I missing where to capitalize it? I thought ToTitle might do it, but ToTitle doesn't do it. ToTitle, yeah, just also uppercases things. Yeah, that's fine. we could also to lower if we wanted to. Anyway, that's a scenario that you're going to see in this week's lab. Wow, that's all the stuff. That's good, because then I don't have to run much over an hour and a half to do some Project 3 stuff with arrays and slices if I want. Okay, so that's about all that I have to offer on those things. I am going to fire up the lab. I'm going to post this code. So this code goes for the ride. It'll appear on the lecture page. The lab code will not, but I will at least do a walkthrough on all of them, and then I will we'll work together on the hard one. Lab 11, which feels darned good. All right, let me get the lab. I can see chat again. Okay, the lab. So, create an empty. So, an empty slice named numbers of integers. Well, it's called numbers. It is a slice of integers. That's how you create an empty one. There's no prefix size like we'd use with make. That would be an empty one. So you know how to print them out in their default format. You know how to print out the length. We have done an example of appending. Default format, length again to show that the things got appended. And you can, when you append, do the append a whole bunch of stuff at once style, or the append things one at a time style. Either way is fine. So that one hopefully is fairly straightforward if you watch the lecture and have the samples that I did that'll be posted to the lecture page. Okay, a float. Well, it's not really pressing us very much, is it? Empty slice of float 64, named temperatures. That's how you create an empty slice, float 64. Printed in its default format. We know how to do that. Declare a variable called input. So this is in the samples from just a little bit ago where I created an input, although this one will need to be a float 64. I did a counting loop in the samples where I prompted for and I read in 5 integers instead of floats, and I appended each one to the slice. So there's an example, but with integers in the sample that I will post to the lecture page. Also can be viewed. Well, if you're here this far in the video, then you'll know that you just saw it. 11, 12, and 13 is the same. Compute the sum, print the sum, compute the average, print the average algorithm that we did last week with an array, but that doesn't matter, does it? Because the loops don't change. I left the sum variable here to remind you that you need that for computing the sum. But this algorithm, this section of the code is the same as one that we did last week. So if you didn't get how to not hard code the denominator for computing the average, that's in your lab notes, and I also talked about it earlier in this same video. So hopefully you saw that, and or at least now you can remember to cycle back and look at it. All right, nothing new there. All right, new stuff here, although this is very much like the colors scenario, but I'm going to go ahead and repeat it because I think this one might be the scarier one of the two. All right, so an array, an array, greetings array of 3 strings. So it wants an array and it wants values in there. Hi, hello, howdy. You've seen something like that before. Use a make function to create a slice of strings of equal length to the greetings. So the same scenario, kind of. We had the original greetings. We would like to alter them, but not destroy the original set of data, so we'll simply make ourselves a slice and do the alterations there. New greetings. Here it says use the make function. I know I'm creating a slice of strings, and I know I want it to be the same length as the original greetings array. Not hard-coded. Don't hard-code the length of arrays and slices just ever. It's a very bad practice. You will introduce bugs into larger software and regret it. Okay, so it is already showing me, it's already got some print statements here. What the new grading should look like, by the way, is basically nothing, although there will be a little space between the square brackets because there's 3 empty strings in there waiting for something to happen. There, nicer. Okay, number 17. Use a range loop to do the following. It's the same one. So, range loop over the greetings, the original data set. I'm going to go through the original data set, do something to the original data. Okay, so I thought this was telling me to print or something. It's just reminding me that if greetings at 0 is high, new greetings at 0 should be all caps high. Well, we know how to do that. Let's make sure that the import has strings in it. It does, so that's taken care of. All right, so we're supposed to go through the old greetings and make new greetings of it. We've already seen that we're simply going to write into the new greetings at the same locations as we get stuff that we have uppercased from the old greetings. So I'm going to use the N that I'm capturing from the range loop of the old greetings and the I that I'm capturing to make sure that high from position 0 in the old greetings goes to all caps high in the new greetings. And then it's already printing for me. And then make sure that you call the 3 slice functions so that the program does something. Okay. That's the lab. It's probably, other than that algorithm that we've now sort of talked about twice and done twice, the rest of it, with a couple of hints, is fairly straightforward. And also entirely covered in the sample. And I will post the sample code on the lectures page with the lecture video when we're done here. All right, there's that. So I'm going to put a small break in. It's 4:57. I'm going to put a 3-minute break in, and at 5, I'm going to do project 3, and I'm going to introduce an array, possibly both an array and a slice, so you can see how you might build some game mechanics, some adventure game mechanics using arrays and slices. So I've got a lot of time to work on that tonight, which means that you'll get to see, I think, a fair amount of me working out some ideas in code. So I'm going to put a break here so that later viewing might be more convenient if you need to stop or want to stop and come back. Following the break is some project 3 assistance, my ideas in code. Okay, so this will be version 2 of my project 3. Hopefully you watched last week. If not, then you won't have seen this before. But I have my little what did I call it? Crazy Caves adventure game started. All I really have is some basic navigation right now. My basic navigation here in main consists of telling the player where they can go or quit, getting their choice of where to go or quit, and then steering them to one of the specific locations in my map. So this is what the map looks like in code. I call it a hub and spoke design because main is kind of the hub, and it just kind of spits you out into those functions, and then you come back and then you keep cycling through the different choices. But let's add, well, let's do a since we're talking about slices this week, let's just keep going with slices, and let's make ourselves, I'm going to do it here, I think here at the top. So this will be my player data section. And let's just add an empty slice called items, which will be string slice, right? So there should be no items there, and we're going to prove that here in a moment by adding this to our menuing system. So there is our player data items, which is an empty string. Let's add a new menu option that lets people view their items. I think I will call it view my items. So I can expand the menu very easily simply by adding another option. Of course, I need to be careful that the character is unique. TAMVQ, we're still fine. And then I'm simply going to add, I think right here above the quit option, choice equals v, or choice equals little v. Otherwise, I would be a very mean person to my user. So we have two choices here. We could make a function for this, or we could just do it right here in place. So you haven't seen me pass a slice to a function. So I think what I'm going to do is show you how to do that. Yes, that's what I want to do. So let's make a function called view items and pass the items slice to it. So view items, passing an items slice to it as a parameter, and I will show you how to code that so that you can create functions where you can pass your slices to them. So let's create a view items. I'll just add a new function up here, func view items. What I should be getting is an items slice of strings. Hopefully I'm doing this right. And then I'm going to do a little logic. So if the length of items is 0, meaning they have no items, then I'll print that fact, right? So print f, you have no items. So I know that the structure of my program and some of my usages might be a little bit new, but if I have a slice of string called items, here it is, I can get the length of it. And if I have the length of it, I can do things like compare the length against 0. If the length of the items is 0, that means there's nothing there, and I'm simply going to print a special message saying you have no items. And then we will have an else part at some point. Your items, but we don't know how to do that yet. So print items here. So let's just see if this works, and then I'll make fixes as I have to. But let's just see if we can prove that we have no items to start. So the whole sequence is, in main, I have my player data, which is this item slice. And Slices declared like this are empty, meaning they have 0 items in them. 0 strings are in that empty slice. I added a menu option so that the user can press a V and say, I want to see my items. I added to my decision tree the ability to deal with that V. If they pick V, I'm going to call a function, view items, and I'm going to pass the items slice to it. So that items, if I can get them both on the screen, not like that. How do you, okay. So this items here is the same, yeah, you can see them both, items that I've declared up here in main. All right, so what does it look like in the view items function to receive an item slice? It looks like this. Items, which are a string slice. I know it's a slice because there's no number here. And then I'm doing something slightly new, but the logic of it, I hope, makes sense. I can take the length of any slice, and I can see if it is equivalent to 0, meaning it's still empty, there's no items there. Otherwise, there's probably at least one item there, and I need to figure out how to print that. But let's start just by seeing if we can view our no items. Or I made a syntax error somewhere. Okay, so there's my running program. If I view items, it should say, you have no items. I'm very happy with that. I'm about to cheat. And I'm going to go, was that project 2 that had that stuff? I think it was. I'm going to go to project 2 and get the pause and clear functions out of it. Ah, yeah, these things I want. So I want pause and clear because they are going to improve the quality of my user interface significantly. Okay, because what I want to do is every time they go to a location, I want to pause and clear as they come out of it. So for now, I'll just pause here and then clear the screen. So after we view the items, I'll pause the system and then clear the screen. And I'm going to do that actually after every location. And all I did, I didn't write these, I just stole them off the second project. They were already written for us, i.e. I wrote them. All they do is, well, you'll see. If you haven't, many of you used them and have been using them. Okay, quit the game, yep. All right, let's see if the new, oh wait, I should clear the screen right at the very beginning. That would look nice. Welcome to Crazy Cave, yeah, right here. Clear screen. And then I think I'm going to pause and clear the screen right after that also. All right, so here we go. Clear screen. There's the pause. The press enter when you are ready is the pause. So when I press enter, it will clear the screen. There's my menu. So I'll view my items. I should have cleared right then too, shouldn't I have? Yes, I should. You have no items. Press enter when you are ready. I should definitely clear right there. Kill that. So I should have cleared. I wonder if I could just clear before I go to any location. That might save me some work. So right after I get the choice, I'll just clear the screen before I go anywhere. Let's see how that looks. Okay, view. Yes, much better. I like that way better. Yes. Okay, that's good. Now let's add an item. So the way I'm going to add items is I'm going to pass my items slice to my location. So let's just start with a treasure cave and get some, I don't know. If anyone in chat can think of a piece of treasure. I'm going to update my treasure cave function. I'm going to pass my item slice and I'm going to put something in there when they get to the treasure cave. So treasure cave. Here we go. I want it to receive my slice of items. And I'm going to give them something. Ruby, okay. We have found a ruby. And then we will items equals append items ruby. So if we go to the treasure cave, we ought to get a ruby. Now, we're going to have to eventually develop an algorithm to not give them 2 rubies, but let's just see if we can go pick up that ruby from the treasure cave. So going to the treasure cave. There we go. I found a ruby. Let's go see if it's in my items. Oh no. Why isn't it in my items? I wonder if I have to do a little trick here. That feels wrong. Let's do this instead. So we're going to have to do a slightly more complicated, or we could. No, let's do it this way. Let's have it take in. We'll have it take in, and then we will have it return the appended stuff. Well, let's do it this way so you can keep track of what I'm doing. So we're going to have to send the items back. Now this is trying to help some of you get a little bit ahead. So I'm going to take in a slice of items and I'm going to return a slice because it didn't work to just take it in and update it. We should have that ability next week to simplify this, I think. But this week we don't. So we haven't talked about expressions. So we will take in a slice, we will return a slice, which really just means update the items by appending something to it and then return those items. Which means that when I go to the treasure cave and pass my items, I get new items back. So I'm going to capture that. Stop the program and rerun it. Let's see if I got my items now, because I want that ruby. Oh, I didn't print them. Well, at least now there's a reason I didn't print them, dummy. I said you have items, but I didn't print them. I'm going to print them all on the same line, I think. Yeah, I forgot this little part. And then I'm going to need to put a new line at the end of that. Probably 2 of them. So I'm not putting new lines in any here because I want all the items across the screen. So your items, there's no new line. And then the items themselves will go across the screen. After I'm done looping through all the items, I will print 2 new lines. The one thing that I see here inside of my loop, I'm only using the data part, not the index part. So I will ignore that. Okay, let's see if I get that darn ruby. I want it and I want to see that I have it. Oh, there's a space missing. Well, let's nip that in the bud right now. All right, here we go. Treasure cave. I found a ruby. View. All right, I got the ruby. I'm very, very happy about having the ruby. It's 5:15. I'm going to do one hard thing here. So if you want to puzzle over this, it's fine. I know I've done a couple of sort of fancy things in here so that if you have this idea that you want to go around picking up items. But I'm going to add the algorithm for detecting whether or not I already have an item. So the way I'm going to do that is I'm going to write a function for that. Have item. and what item and in what slice should I be looking. And then true or false, I have that item. So I'm going to specify an item to look for in a slice in which to look for it, and then return true or false based on whether or not I find the item in the slice. It's actually fairly simple code to write. So we will say var has item bool, and we have to assume initially that they don't. Now we will range loop. So in equals range over items. And if, we could be fancy, but let's not be fancy yet. If the item in the slice is the same as the item I am looking for, then I have it. And I can break out of the loop because I don't need to look for it anymore. In the loop, I notice I'm not using the I, so get rid of that thing. And then after the loop, I can return that has item. It assumes we don't have it, but if we can find it in the slice, then we will say yes, in fact, we do have it. So anyway, I will put a link, like I did last week. There will be a link to this version of Project 3 to give you some ideas you can work with. Okay, so how do we use have item? Here in Treasure Cave, we can say if you don't have the item Ruby in your items slice. So this means not, which is the opposite of yes. So we're saying if you do not have the item, then I'm going to give it to you, which means I need to append it there as well. So now we have the ability in the Treasure Cave to detect whether or not you've already, in fact, found it so that you don't get two. So only if you don't already have a ruby in your items will you be given one. Let's see if it works. Nope. Oh, dummy. Singular. This item is what I'm looking for in the set of items. That was an easy typo to make. I'm looking for one specific item inside of the grouping that's items. All right. Here we go. Crazy caves. So the first time I go to the Treasure Cave, I should find the ruby. I did. That's good news. And I'll view that. There's the ruby. If I go back to the Treasure Cave, in theory, it won't give me a ruby. At least it says it didn't. So let's go view my items and see if it messed them up. Nope. Same items I started with. I'm pretty pleased with that. I will go do one more example so that you can see the whole process again. The mystery cave. All right, this is, so we need to pass the items to the mystery cave and then also return any updates that we make to the mystery cave. So we make sure we return the items. Okay, so if we don't have item, I don't know what item to put in the mystery cave. So the last thing I need is what item do I give them in this mystery cave? What sounds mysterious? I'll put a locked box in there. Amulet. Okay, amulet's way better. I like amulet way better than locked box. Thank you, Kevin K. All right, so just to have shown you a second example of this. So this, you could use this kind of setup to have a game where the player kind of goes around trying to collect the right kind of items. After next week, we'll be able to actually consume an item, meaning we'll be able to remove the item from the slice, which means they could go and then use it somewhere, I'm looking forward to doing that with now my amulet. And maybe I can sell the ruby for gold or something next week as well. Okay, so anyway, it's just another test. So you've seen in the mystery cave, I need to make sure that when I go to the mystery cave, I send what I have for items in there, and I retrieve whatever items I found in the mystery cave. No items. I'm going to go to the adventure cave first, which should not give me any items. Good. Go back to the treasure cave. I'll find a ruby. I'll go back there again. I shouldn't find it twice. Have a ruby. If I go to the mystery cave, oh, I forgot to fill it in. Now I got to do the whole thing over again, except for I'm not going to do all the extra tests. I forgot to fill in the blank. You have found an amulet. All right, so let's just go get the goodies. If I go back, I don't get it twice. There it is. If I go to the treasure cave, view my items. Now I have 2 items. And then I can begin to develop some gameplay around what to do with these items. So anyway, there's a little bit of bonus material in there because I am passing slices to functions. I think maybe we do that next week. Hopefully we do that next week. So this puts you a little bit ahead. So this link to this REPL will be on the lecture page, just like it was last week. So either of those, last week's lecture and this week's lecture, will take you to the same now updated version of my Project 3 that has no creativity in it other than Kevin K's Amulet and Ruby, but I haven't put any story in here or any interesting descriptions or anything, but I do have some technical mechanics working, right? I now have an item slice and I can go pick up items and then I don't get them twice. Okay, that's where I got to stop. It's 5:23, so I'm a little bit early. Thank you, Kevin K, for the assist. Everybody else, hope you have a great week. And if you're watching the video later, hopefully you are having or have had a good week. Lab tips and project tips will be uploaded as links to my REPLs. And then, of course, the videos will be uploaded in all the usual places as well. So I will see you on Tuesday afternoon next week. New slice and array techniques that will give us some additional capabilities with our adventure project. So I will continue on my Crazy Caves project to try to give you some more ideas that you might use in your own project. Okay, that's it for me. Have a great night.